Okay, so we're picking up where we left off yesterday. We're reviewing properties of the normal distribution, how to find probability or boundary values, all of that fun stuff. We're going to start with another example. So this one says the diameter C of the top of a randomly selected large drink cup at a fast food restaurant can be modeled by a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inch. The diameter L of a randomly selected large lid at this restaurant can be modeled by a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02. Assume that L and C are independent random variables. For a lid to fit on a cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inches. Let the random variable D equal L minus C, be the difference between the lid's diameter and the cup's diameter. And it says describe D and then find the probability that the lid will fit the cup. Yeah. So a lot to unpack, yes? Practicing for FRQ questions. So let's start with the two distributions they gave us. So what two distributions did they give us to start with? Diameter of the cup, which we called C. Good. They told us C was normal with a mean of 3.96 and a standard deviation of 0.01. Did I do that correctly? I think I did that correctly. Yay. Good. They gave us another one. What was the other distribution? The lid. Very good. L, which was also normally distributed with a mean of 3.98, standard deviation of 0.02. Good. I, as the person selling the soda at a restaurant, want to make sure that the lids fit my cups. So I'm not interested in C and L as much as I'm interested in the difference. So we want to look at D, which equals L minus C. And I need for L minus C to be greater than 0, but less than 0.06 inches. Too small, it won't fit. Too big, it won't stay on. And A says describe the distribution of D. So we're looking at a difference between two random variables. If those two random variables are normal, what do I know about their difference? Also normal. Good. So I know D is normal. So D follows a normal distribution. I know for a normal distribution, I need a mean and standard deviation. So the question is now, what does the mean of D look like? What does the standard deviation of D look like? So for the mean, I find D by doing L minus C. How do I find the mean for D? Yep, mean for L minus mean for C. Good. Whatever we do to the data, we do the same to the mean. So this is just the mean for L minus the mean for C. And we have those values. L was 3.98 inches. C was 3.96 inches. So that's 0.02 inches, I believe. I see nodding. Good. So that's the first value here. And then the slightly trickier question. So we know if I'm taking a random variable and I'm adding or multiplying, the standard deviation is only affected by the multiplication. Just straight multiplying. But this is not a random variable times a number. This is a combination of two different independent random variables. There is a different rule here. if I am squishing together two different random variables, this was that ugly square root of the sum of the squares. The one that you all groaned at in our last unit. You can remember that as just plug and chug. Trick is remembering that. Yeah. You combine random variables, square root of the sum of the squares. So square root of 0.02 squared plus 0.01 squared. And that I cannot do in my head. I get 0.022. How did I see nodding? Thank you, Kaylee. Happy face. We have described the distribution for D. Normal mean of 0.02, standard deviation of 0.022. Yeah. Good. And then B, now that I know what the distribution of D looks like, says what is the probability that a randomly selected lid will fit on a randomly selected cup? Describe this probability in words. So for B, my pen hates me. There we go. For the lid to fit, we had a relationship between the lid diameter and the cup diameter. There were two conditions. What were those two conditions? L has to be bigger than C, so I want the difference to be bigger than 0 when I subtract L minus C. Good. What else? No more than 0.06 inches. Good. So D should be less than or equal to 0.06 inches. Good. So that is those are forming the boundaries for my probability. Because they're asking, what's the probability that it will fit? So probability that it will fit, I'm looking for D to be between 0 and 0.06. And remember yesterday when we're looking at continuous distributions, the less than or equal to gives you the same answer, so you can't really mess those symbols up. If you just wrote less than, you'd get the same answer. Good. 2 steps. Picture, calculator. Yeah? We draw our nice, pretty normal distribution. We are looking at a distribution for D. Mean is in the middle, 0.02, and then 3 hash marks in either direction. Going forward, I'm adding the standard deviation. Backwards, I'm subtracting it. So forward, I'm adding 0.022. So 0.042, 0.064, 0.086. I think I did that correctly. I don't hear any arguing. I'm going to assume I did. Going backwards, I'm subtracting 0.022. So that's going to be negative 0. Oh my gosh. I can do this in my head, but I'm not really awake. So negative 0.002. 0.02 and 0.24 and 0.46. I think I did that correctly. Reminders for the multiple choice, you don't need the picture. It helps if you can quickly sketch it, but it's not necessary. For FRQs, you need to write it. You need to label the variable that's being plotted. You need to label those hash marks on the mean. Those have to be there. Good. I'm going to mark my boundary values. So 0 is a little bit to the left of my mean. I don't know why I made that so tall. And 0.06 should be a little bit to the left of 0.64. And to find the probability that I'm between those two values, I'm looking for the area between those two values under the curve. So I want that. You okay? Okay. And the question is, how do I find that value? And this is where the calculator come in. What calculator function call do I want? Normal CDF. Very good, as a class. Normal CDF, which is in second vars. Normal CDF asks for how many things? 4 numbers. Very good. Lower bound for the shaded area. Upper bound for the shaded area. Mean. Standard deviation. Good. And we should have all that. So upper and lower bound came from our picture. And from knowing that the lid needs to fit. Good. What mean do I shove in here? 0.02. Good. This is D, not L or C. And this would be 0.022. Perfect. And you're going to get your calculator and check that I do this correctly. Huh, that's funny. And I did it. I got 0.784 rounded. Did anybody else get 784? I see you nodding. Thank you. Which is funny because I think we got that for an example yesterday too. Yeah. Completely unrelated. Very good. So that represents an area of 0.784. My picture, that red shaded area, is about 78.4% of the area underneath that curve. Am I done with the problem? No, very good. I need to write my sentence. Interpret what that number means in the context of the problem. So when we are talking about probability, we're talking about a randomly selected cup and lid. Yeah. And there is a 78.4% chance that that randomly selected lid will fit that randomly selected cup. Come on, pen. as the owner of this business who is selling sodas in cups with lids, am I happy with that percentage? No. That's almost a quarter failure rate, right? 1 out of 4 is not going to fit. That's not great odds. So I may want to start purchasing lids that have a smaller standard deviation, that are more consistent in size. Yeah. Good. Good. Yeah. Questions on that last example? No. Okay. I think we have one more. One more. Good. Do I have a volunteer who wants to read the prompting and the first thing they ask us to do? Thank you, Jeanette.
The amount of liquid soap X dispensed by an automatic soap dispenser each time is activated to be modeled by a normal probability distribution with a mean of 0.9 milliliters and standard deviation of 0.042 milliliters. Calculate the probability that the amount of soap dispensed is less than 0.8 milliliters when the dispenser is activated once.
Very good. Thank you, Jeanette. So we're going to do the whole state plan do conclude thing here, the whole FRQ process from start to finish so that we know what it looks like. Yeah? It's good for us. So state means I need to define any variables in words, identify any information that I'm given. Yeah? So in that statement, what is my variable? X, and what does X represent? Very good. Amount of liquid soap dispensed. So I'm going to write that on my paper in words. X equals amount of liquid soap dispensed. And because I am also a science nerd, I am going to record the units because that is good habit. Is the amount in milliliters. Good. And then I identify what they gave me about that system. So what does the distribution of X look like? What type of distribution? Normal. So X follows a normal distribution. The mean is equal to what? 0.9 ml. And the standard deviation is equal to 0.042. Good. Good. More writing than we've been doing in the past, right? Everything is nice, neat, explicitly labeled. It's good for you. And that was all we were given, right? Just what that distribution for soap dispense looked like. And then we come to 1. It says calculate the probability that the amount of soap dispensed is less than 0.8 ml. So I'm going to write that problem using appropriate probability notation. Yeah. So probability is P, amount of soap dispensed is X, and I want it to be less than 0.8. Yes, this is what I want to find. And then the do is the picture and the math. And then the conclude is the sentence that follows it up. So I need somebody with a calculator ready to help me label the hash marks, because I cannot do 0.042 in my head while I'm subtracting. It's too much for this time of day. perfectly symmetric, but we'll work with it. That's the best I can do for now. Mean goes in the middle, so 0.9. And I know going forward, I'm adding 0.042. So 0.942, 0.984, 1.026, I think. Please check my math. There are 25 of you in class. No one has checked my math. Y'all have calculators. Come on, check my math. Did I do that correctly? Ariana is confirming. Caleb's confirming. Very good. Now we need to go backwards and start subtracting. 0.9 minus 0.042. 0.858. Yes. 8. 0.816. Yep. Yes. Next one you're going to have to give me. It's 0.7 something. 774. Thank you. I could, but we'd be here all day waiting on my brain to calculate. Good. Very good. I mark the area of interest in my labeled picture. So I want less than 0.8. 0.8 is way down here. Less than 0.816, more than 0.774. So I want this area in this tail. I am out past the second standard deviation marker. So I know that this probability is going to be small, less than 2.5%. Because if 95 is in the middle, 2.5 on either side. And I'm out past that marker, less than 2.5%. I am expecting a small answer. And then we're going to calculate. I'm looking for probability for a normal distribution. That's normal CDF. What is my lower bound? 0. You'd think, right? You could technically use 0 here, but what do we do as default? Because we know this model technically goes forever. Yeah, negative 1e99. Good. Yes, in reality, it stops at 0. Our model goes to infinity. And so we're going to go out to infinity. Usually it's going to make very little difference, but it's better to be precise with the model. Good. Upper bound. 0.8, perfect. And then we have the mean and standard deviation above. So mean is 0.9, standard deviation is 0.042. Perfect. So Px is less than 0.8, and L is 0 point something. I see nodding. Caleb, what do you get? 0.086. Can I get thumbs up if you got what Caleb got? I see thumbs up. I see a bunch of people blindly copying without testing on their own calculator, frowny face. Did you also get 0.008? Yours kept saying error. Did you use subtraction instead of the negative button? Comma. Above the 7. I'm going to assume we did that correctly for now. State plan due. I need my conclude. What am I missing? Sentence. Very good. The writing portion of the math class. Sad face. So what were we asked to find? And I'm going to go back up and I'm going to look. Probability, yeah. I'm lazy. I freaking hate writing. I hate it so much. That's why I majored in math and science. Yeah, I do not like writing. I'm going to pull wording from the question. Probability, the amount of soap dispensed is less than 0.8 milliliters. I am going to copy that down below and then tack my answer onto the end. So probability, the amount of soap dispensed is less than 0.08. Probability. Amount of soap dispensed is less than 0.8 ml, and there was some more after that. Wow, a copy here. When Spencer is activated once. Thank you. Why does it hate me? Is, and then I write my answer. 0.080086. State plan to conclude. Happy face. Is that numerical answer makes sense in terms of what we expected based on the normal curve and the empirical rule? I see some nodding. It was less than 2.5%, but bigger than 0. Yeah. Good. Good. Happy face. Happy face. Ooh, excuse me. There are 2 more parts to that question. Because it's an FRQ. It always has multiple parts. So 2 says find the 95th percentile of X. Describe this value in words. I don't have to redo this part. It's at the top of my paper. I don't have to like relabel. Once it's on there, it's on there. It says find the 95th percentile. So the question is, what information have they given me here? 95th percentile. What is that a measure of? Louder, Halo?
Oh, was that right?
I didn't hear what you said.
Oh,
What did you say? No, what did you say? It's a percentage or another P word. What are we finding here usually? Probability. Yeah, it's a probability. We know that percentiles are the probability that a randomly selected value is less than or equal to that number, right? Or the percentage of people that are less than or equal to that number. We can interpret it both ways. So they have given me a probability. They have given me the probability that X is less than or equal to whatever number I'm looking for here. So I'm letting the 95th percentile be equal to A. I need to find what A is. I know the answer to this probability question is 0.95. I have the answer. I want the boundary value. This is the opposite of what we did in the last example. Which function do I want on my calculator? Inverse norm. I am going to go back up here to our picture from the last part and use a different color to mark it up for what we're doing now. I'm going to use blue for number 2. I know my 95th percentile should be a little bit less than the second standard deviation marker. because second standard deviation to second standard deviation is 95. I want 95 less than or equal. So I suspect I'm somewhere in this area here. I don't know exactly where, but I suspect A is sitting there. And I know that this area in blue is 0.95. Yeah. Didn't redraw the picture. Just different thing. Mark on the same picture. So I expect it's going to be 0.9 something. I have to figure out 0.9 something what. And you guys said inverse norm. Yes. Which I agree. So A is inverse norm. And if you pull up inverse norm on your calculator, what does it ask you for? Very good. And specifically, we're going to do to the left. So area, mean, standard dev, tail. I'm going to start at the bottom. I know my tail is a left tail because percentiles are always left tails. So this should be left. I know the area to the left of that boundary value is the percentile, 0.95. I know my mean and standard deviation. Mean was 0.9, standard deviation was 0.042. I get 0.969. Let me see some nodding. And we go back up and we look at our picture. Does that look like we marked it in the right spot? Yeah, pretty darn good. Between 0.98 and 0.94, that's 0.96 something. We did pretty good with that. So knowing your empirical rule is going to help you mark up your pictures so they accurately reflect what you're doing in your answer. Good, good. You should, if we're doing the whole state plan, conclude, then write the sentence. The 95th percentile for soap dispenser amount is 0.969. And what are the units on that? Milliliters. Good. We're looking at amount of soap. Good. One more part. It's good for you. Let me scroll up because I have horrible big writing. Okay, last part. Some experts suggest that at least 1.6 milliliters of soap, liquid soap, should be used by someone washing their hands. Suppose that the amount of soap dispensed on one activation is independent of the amount dispensed on another activation. Determine the probability that a person will get at least 1.6 milliliters of soap from the dispenser if they activate it twice. And some of you have dead fish eyes. Come on, wake up. Good morning. So I want the probability I get at least 1.6 milliliters of soap if I activate it twice. What am I doing to my random variable? Multiplying by 2. Yeah, I'm doubling it. First dispenser, second dispenser. I'm doubling it. So 2 times x. So I am not looking at the random variable x. I am looking at the random variable 2x. So the very first thing I'm going to do is I am going to define a new random variable. What should we call our new random variable? Pick a letter. Stacia, pick a letter. T? We'll go with T. T for total. T is 2 times x. Yeah? And T equals the amount of dispensed on 2 separate dispenses. Yeah? have to write the words because I'm defining something new that wasn't on the paper before. I don't have to redefine x. They know what x is. I have to define t. Before I find probability for t, I need to define its distribution. So if x is normal, what do I know about t? T is normal. Perfect. So t follows a normal distribution. I need a mean for t. I need a standard deviation for t. So if I multiply my data values by 2, what do I do to my mean? Yes, the same thing. So 2 times 1, not 1, 0.9, yeah, would be 1.8. Did I do that correctly? Yes, happy face, 1.8. Perfect. Standard deviation. If I multiply my data by 2, meaning I grab the edges of that normal curve and I stretch it outward, what do I do to my standard deviation? Multiply by 2. Yeah, good. Standard deviation is only affected by multiplication, not by addition. Good. So 2 times 0.042 is going to be 0.084. Happy face. And then the probability stuff. New normal curve. New probability statement. And you are groaning. I know you are groaning because I know this feels tedious. Everything we're doing next semester depends on the normal curve. You have to know how to draw these quickly. Yeah, it should be just default. If you're doing something with normal, draw the picture. Like you got to be at the point you're doing it without thinking. This is your new favorite shape, guys. New favorite shape. Oh, I know that feeling. 1.8, hash mark, hash mark, hash mark, hash mark, hash mark, hash mark, slightly better than the last one. 1.8 plus 0.084 is 1.884. 1.968 and 2.052. And then 1.716, 1.632, and 1.548. Calculators are your friend. And I want the probability that the person will get at least 1.6 milliliters. They asked me for this. At least 1.6, so greater than or equal to 1.6. So I'm going to come to the picture. I'm going to mark where 1.6 is, which is way over here. Which way do I shade? To the right. Very good, because it's a greater than. I need at least that amount. More is great. Big number or small number is my answer. Big, very big. Pretty close to 1, yeah. Because I'm way out here past the second standard deviation, and I go all the way to the right. So big, very good. Finding probability, which function do I use in my calculator? Normal CDF, very good. on your homework while you were practicing this week, you notice how I do that rapid fire. I do it all at once because I know what normal CDF asks for. That is the point you want to be at. It's not going to happen today, but we're practicing consistently so that next semester that starts to feel more familiar. Okay, Ariana, what's my lower bound? 1.6. Very good. Julia, what's my upper bound? Very good. Goes forever and ever and ever on the right. Perfect. And then we found the mean and standard deviation for t. Mean is 1.8. Standard deviation is 0.084. And I got 0.991. I see nodding. And that's about what we expected, a little bit less than 1, because we shaded in most of the curve. Last thing we should do, write it out. I'm not going to do that now because we're tired. But every time you write a number, you should accompany it with a sentence, yeah? So the probability that a person gets at least 1.6 milliliters on 2 separate presses of the pump is about 99.1%. So if we want to be sure they're getting enough soap to get their hands clean, they should be using 2 presses. Though science actually says that it's more important that you scrub than it is that you use tons of soap. It's this with running water that helps. The joy of having nurses for parents. Yay. All right. Questions on the second example? All right. Before I set you loose for homework, notice that this problem involved multiple pieces of knowledge. I had to know how to find probability and boundary values for a normal curve in general. Normal CDF and inverse norm. That's a fundamental skill. I also had to recognize when I was combining or modifying a distribution and what those modification rules look like, what I do to the mean and standard deviation. So all of that is something that needs to be solid and up here by May. Yeah, we're going to continue practicing for the rest of this week. You've got a little bit of homework time. We'll start on 5B when I see you tomorrow. Yay.